What if the future of electric cars is about to change again? Just when the world thought electric vehicles had already reached their peak of innovation, a new concept linked to Elon Musk is stirring intense debate across the automotive world. Engineers, analysts, and EV enthusiasts are asking the same question. Has a breakthrough arrived that could redefine how electric cars work? Because if this new engine concept delivers on its promise, it could challenge everything we thought we knew about performance, efficiency, and the future of electric mobility. Through Tesla Incorporated, Elon Musk has already forced the global auto industry to rethink transportation. Before Tesla, electric cars were often slow, limited in range, and mostly seen as experimental technology. To understand why so many engineers and analysts are watching closely, we have to look at the bigger pattern behind the innovations coming from Elon Musk and Tesla Incorporated. Throughout the past decade, Tesla has repeatedly introduced ideas that initially sounded ambitious, but later became defining standards for the industry. Long driving ranges, high-performance electric sedans, software-driven vehicles, and over-the-air updates were once considered experimental concepts. Yet today, they are becoming expectations for modern electric vehicles. This is why even the possibility of a new propulsion concept has captured the imagination of automotive engineers and technology enthusiasts across the world. What makes this moment particularly fascinating is that electric vehicles are already highly refined machines. Unlike traditional combustion engines, which rely on hundreds of moving parts and complex fuel systems, electric propulsion is naturally elegant and efficient. However, innovation never truly reaches a final destination. Engineers constantly search for ways to refine magnetic fields, optimize energy flow, and reduce resistance within motors. Small improvements in these areas can lead to dramatic gains in efficiency, range, and overall performance. A motor that operates just a few percentage points more efficiently could allow an electric car to travel significantly farther using the same battery capacity, which is one of the most valuable breakthroughs the industry could achieve. There is also an exciting possibility that the next generation of electric propulsion may focus on simplifying components while enhancing performance. In advanced engineering circles, discussions often revolve around ideas such as higher-density motor architectures, improved thermal management systems, and more refined magnetic structures. These developments may sound technical, yet their impact on everyday drivers could be extraordinary. Imagine electric vehicles that accelerate smoothly with even greater responsiveness, travel longer distances between charges, and require fewer materials to produce. Each of these improvements contributes to a future where electric mobility becomes more accessible and more practical for millions of people. Another reason this concept has drawn attention is Tesla's unique approach to engineering. While many automakers rely on long development cycles and cautious updates, Tesla often approaches problems from a completely fresh perspective. Instead of simply refining existing technologies, the company frequently asks a more fundamental question: how can the entire system be redesigned to work better? This philosophy has guided many of Tesla's breakthroughs, from battery pack architecture to vehicle software integration. As a result, every new idea that emerges from the company's research laboratories invites speculation about how transportation might evolve next. The ripple effects of such innovations extend far beyond one company. The global automotive industry is currently undergoing one of the most significant transformations in its history. Companies like Toyota, Ford Motor Company, and Volkswagen Group are investing immense resources into electrification, each exploring different strategies for improving battery performance, motor efficiency, and charging infrastructure. When one breakthrough appears in this rapidly evolving landscape, it encourages others to accelerate their own research. In this way, a single innovation can influence the direction of the entire industry. Beyond performance and engineering, there is also a broader environmental and societal dimension to consider. Electric vehicles represent more than just a new type of car. They are part of a wider transition toward cleaner and more sustainable energy systems. When combined with renewable electricity sources, electric transportation has the potential to reduce emissions, improve air quality in cities, and create a more resilient energy network. Every improvement in motor efficiency or battery design contributes to this larger vision. The quieter streets, cleaner air, and more sustainable transportation systems of the future may all be connected to the technological choices being explored today. At the same time, innovation often unfolds in stages. A concept introduced in research laboratories may take years to refine before it appears in production vehicles. Engineers must carefully test new designs, evaluate long-term durability, and ensure that safety and reliability remain uncompromised. Yet the process itself is part of what makes technological progress so captivating. Each prototype, experiment, and design improvement moves the industry one step closer to a new generation of vehicles that are smarter, more efficient, and more connected to the energy systems of the future. What makes this story even more compelling is that electric vehicle technology is still evolving rapidly. Batteries are becoming more energy-dense, charging networks are expanding across continents, and software systems are turning cars into intelligent machines capable of learning and adapting. Within this dynamic environment, a new propulsion concept could become another turning point in the timeline of electric mobility. It might influence how vehicles are designed, how they perform, and how drivers experience them in everyday life. As researchers continue exploring these possibilities, curiosity around the future of electric propulsion continues to grow. Enthusiasts, engineers, and industry observers are watching closely, eager to see how the next chapter unfolds. Whether the concept ultimately becomes a revolutionary product or simply inspires further innovations, it represents the spirit of experimentation that drives technological progress forward. And in the rapidly changing world of electric vehicles, even a single new idea can spark an entirely new direction for the industry. And perhaps that is the most exciting part of this unfolding story. The future of transportation is not a finished picture. It is a canvas still being painted by engineers, visionaries, and innovators who continue searching for better ways to move the world forward. Somewhere within research labs, design studios, and testing facilities, the next breakthrough may already be taking shape, quietly preparing to transform the roads of tomorrow. And as the canvas of the future continues to be painted, the pace of innovation in electric mobility appears to be accelerating rather than slowing down. Across research centers and engineering laboratories, teams are studying every detail of how energy flows through an electric vehicle from the moment electricity leaves the battery to the instant it reaches the wheels. Each stage of that journey offers opportunities for refinement. This spirit of exploration is particularly strong within Tesla Incorporated, where the engineering culture often encourages bold thinking and unconventional solutions. The influence of Elon Musk has frequently centered on asking fundamental questions that challenge traditional assumptions. Instead of asking how to slightly improve an existing motor, the conversation sometimes shifts toward imagining entirely new ways for electric propulsion to function. Could motors become smaller yet more powerful? Could efficiency approach levels that once seemed unreachable? Could manufacturing be simplified so that electric vehicles become even more accessible to drivers around the world? These questions guide research that may eventually reshape how vehicles are designed and produced. At the same time, the global landscape of electric mobility is expanding in fascinating ways. Cities are building larger charging networks, renewable energy projects are feeding cleaner electricity into national grids, and consumers are becoming increasingly comfortable with the quiet confidence of electric transportation. Vehicles like the Tesla Model S, the Tesla Model 3, and the futuristic Tesla Cybertruck represent milestones along a journey that continues to evolve. Each new generation of technology brings subtle improvements that accumulate over time, gradually transforming expectations about what an electric vehicle can achieve. Yet what makes the current moment especially intriguing is the sense that the industry may be approaching another leap forward rather than just a series of incremental steps. When engineers discuss next-generation propulsion systems, they often envision designs where efficiency, durability, and simplicity coexist more naturally than ever before. Imagine a motor that operates with such smooth precision that energy losses become almost negligible. Imagine systems that require fewer rare materials, making production more sustainable and resilient. Imagine vehicles that travel extraordinary distances on a single charge while maintaining the elegant simplicity that defines electric mobility. These ideas may sound ambitious, But history has shown that technological progress often begins with ideas that once seemed distant. Meanwhile, the ripple effect of such innovations continues to influence other automotive leaders. Companies such as Toyota, Ford Motor Company, and Volkswagen Group are investing deeply in their own research and development efforts. Their engineers are exploring new battery chemistries, advanced software systems, and efficient manufacturing processes that support the transition toward electrification. The competition is not merely about building vehicles. It is about shaping the technological foundation of transportation for decades to come. In many ways, this shared pursuit of innovation benefits everyone, because each breakthrough encourages further discovery across the entire industry. Beyond the technical achievements, there is also a philosophical dimension to this transformation. Electric vehicles represent a shift in how humanity interacts with energy itself. Instead of relying on fuels extracted from deep beneath the earth, future transportation systems may increasingly draw power from sunlight, wind, and other renewable sources. When vehicles, energy storage systems, and renewable generation become connected through intelligent networks, a new kind of ecosystem begins to emerge. Cars may communicate with homes, homes may exchange power with the grid, and transportation becomes part of a larger, more balanced energy landscape. Within this evolving picture, propulsion technology plays a central role. The motor is the quiet heart of an electric vehicle, converting invisible currents of electricity into motion that carries people across cities, highways, and continents. Improving that heart even slightly can transform the entire system. More efficient motors extend driving range. More compact designs allow for more creative vehicle shapes. Smarter electronics make acceleration smoother and energy use more precise. Every enhancement contributes to a vehicle that feels more responsive, more refined, and more aligned with the needs of modern life. As engineers continue refining these ideas, the conversation around electric mobility becomes increasingly rich and imaginative. Universities, technology companies, and research institutions are collaborating on studies that explore the physics of magnetic fields, the chemistry of advanced batteries, and the digital intelligence required to manage complex energy flows. The result is an environment where innovation emerges not from a single discovery, but from the convergence of many disciplines working together. Physics, materials science, software engineering, and environmental science all play a role in shaping the vehicles of tomorrow. And so the story continues to unfold in quiet workshops and bustling laboratories around the world. Prototypes are built, simulations are run, and ideas are tested again and again until they reach the reliability required for real-world roads. The process may be gradual, yet it carries a sense of anticipation that keeps the industry moving forward. Every improvement hints at new possibilities for transportation, vehicles that are cleaner, more efficient, and more connected to the evolving energy systems of our planet. For those watching closely, the excitement lies not only in the technology itself, but also in the journey of discovery that surrounds it. Each innovation adds another chapter to a narrative that is still being written, a narrative where creativity and engineering come together to redefine how humanity travels. Somewhere within this ongoing exploration, the next great breakthrough may already be forming, quietly preparing to inspire the next wave of electric vehicles that will glide across the roads of the future. And so, the journey of electric mobility continues, guided by curiosity, innovation, and bold ideas. Each new propulsion concept represents not just engineering progress, but a step toward a more sustainable future. The road ahead is full of challenges, yet it is equally full of promise and possibility. Every improvement in efficiency, every refinement in design, brings electric vehicles closer to perfection. What begins in laboratories today could transform the everyday experience of driving tomorrow. Cities may grow quieter, skies may grow cleaner, and energy may flow more intelligently than ever before. Tesla and other pioneers are not just building cars, they are shaping the future of transportation itself. With each breakthrough, the boundaries of what is possible expand further. For engineers, enthusiasts, and everyday drivers alike, the excitement lies in seeing these ideas come to life. And as the wheels of innovation turn, the next chapter of electric mobility is already on the horizon.